Hello everybody, welcome to Dr.K.Liu Math channel. This topic also include the theory of exponential distribution. The meaning of exponential distribution, and I will talk later, but the cumulative means the cumulative function 1 minus e to the power negative x over theta. That means there is an occurrence. There is an occurrence that in the time interval 0 to x. It means, therefore, the corresponding probability density function also have its meaning, but that is a relative interest that the number of it means there is an occurrence. There is one at least one. There is one trial in the interval. It means. Okay, then let's. Here I actually want to talk about the if we give the exponential distribution, fx equal to 1 over theta times e to the power minus x over theta, then the cumulative function is fx capital Fx equal to 1 minus e to the power x over theta. Okay, then by definition, capital Fx is actually equal to the integration of 0 from infinity 1 over theta e to the power negative x theta d theta. After the integration, it is equal to negative e to the power of x over theta. I put infinity into the function, it is equal to, sorry, this is x. I better to, this is x, this is t. I make a series mistake here. By definition is here. This is t. Then put x equal to into this one is negative e to the power minus x over theta. Put 0, it is 1. That's 1. That is the cumulative function. 1 minus e to the power negative x over theta. And for the expected value is equal to theta, variance is equal to theta square. I'm here also use the so-called so-called the mean the basic definition, ex equal to integration 0 to infinity x times the cumulative times the PDF 1 over theta e to the power minus x over theta dx. Using by part, that is these terms can be come together. That is d e to the negative x over theta, negative sign. Then by the formula in u dv equal to uv minus in v du. We have here it is equal to, let me see, negative x times e to the power negative x over theta. That's first part, plus integration, change these two, and the negative size that becomes positive. This is 0. When put infinity into this one, this is equal to 0, and put 0 into this is also 0. That overall is 0. Then for the second part, that is 1 over negative theta times e to the power negative x over theta. Assign the value 0 and theta, 0 and infinity. When put the infinity into, that is 0, and that put the 0 into the function, that is 1. Only negative theta here, that is positive theta. That is mean of the exponential function. And then for the variance, okay, for the variance, I first part calculate the ex squared. That is 0 to infinity x squared. First thing, change these two positions, negative x squared dE, negative theta, x over theta. And by the integration by part, negative x squared. And then plus change of these two. And dx squared. I don't write again. I change this one. This is 2x dx. And this all 0 because when you put 0 infinity into the function and also put 0 into that, two terms are 0. Okay, here I use the integration by part. Okay, I make this two into the function and put this one into the differentiation. That is d e negative to the e to the power negative x over theta times theta, negative 2 theta. The first part, x e minus x over theta. The second part, change the position of these two theta outside, and e to the power negative x over theta dx. And these 2 theta. Wow, so nice. Again, because I have finished the integration of this one, same, it is equal to theta. Then this theta square. Therefore, the variance ex squared minus ex all square. That is 2 theta square minus theta square. That is theta square. That is the third part of that is the variance. Okay, for the moment of generating function, by definition, moment of generating function is equal to e to the power e expected value of e to the power xt. That is integration 0 to infinity e to the power xt times 1 over theta e to the power negative x over theta dx. 1 over theta is outside, move outside the integration side, then x times t minus 1 over theta. Okay, integrate this one, and that has become the denominator. Because this part is constant, related to the x. Put infinity into, and because there is some criteria for the value of t should be less than 1 over theta. Therefore, this must be negative. This is negative. This is a criteria. If it does not fulfill this criteria, this moment of generating function cannot be whole. Then put 0. Put in infinity into the function. This 0 and put 0 into this 1. Therefore, there is negative 1 over theta, t minus 1 over theta, and change the sign here. That is 1 minus theta t. That is the moment of generating function of exponential function. Okay, I hope guys can enjoy this video, because I'm here try to share some the proof of the the mean variant moment of generating function of exponential distribution. Also, and in another video, I try to prove the uniform distribution. Also, I will prove the gamma distribution. I also do some other important theory, and that is video that I make video one by one so that you can learn these topics easily. Okay, I hope guys can enjoy my video. If you really found Dr.K.Liu Math channel is useful, please subscribe my channel. And also, if you can join our membership so that you can get more information in the learning, in the process of learning. Okay, if furthermore, if you have any problem, you also and send message to me, and I hope I can help you to solve this problem. Okay, anyway, bye bye.